In this video, we're going to be doing the turning points and points of inflections of cubic functions. Ne? Here are the keywords that you need to know. If they say stationary points, you know, TP, you know, maxima, or minima, minima, extreme points. They are basically saying the same thing. Eh? Sometimes they'll say, find the extreme points of this function, maxima and minima, or turning points, or stationary points. They just mean one in the same thing. Okay, perfect. So ladies and gents, I'm going to find the turning points and the point of inflection. Let me just write it here so that I don't forget. Point of inflection of this four graphs. Ne? Sharp. I'm going to do them randomly, and I'm going to start with B. Okay. Let's say B was f of x equals to x cubed minus 5x squared plus 1. Ne? And then I'm looking for the turning point. For me to do the turning point, I need to know a very important thing. Ne? Remember, we said the derivative of f of x is basically the gradient of f of x, right? At any x value, all right? So on the turning point, you need to know that the gradient is always 0. Ne? This is very, very important. On maxima and minima, or extreme points, the gradient is always 0, right? Now let us differentiate this. So if you just started by watching this video, please go inside this playlist and watch from the beginning and come advance with the videos, because I'm doing it in such a way that the videos are getting higher and higher and higher with standard. So start from the basics and advance. Okay, perfect. Let's proceed. So in this case, we're going to have the first derivative here. The first derivative is basically 3x squared minus 10x, right? Remember, the derivative of a constant is 0, so the 1 is going to disappear. Here there's a 1, so 1 times 3 is there. Then this times that is there, and then you minus 1s on the exponents. Okay, perfect. But we know that this must be equals to 0. Why? Because we're looking for the turning point. We know that the gradient must be equals to 0. Sure. And then from here, we can easily see that, okay, we need to solve for x now. Ne? So someone can use quadratic formula, but remember, if the c is not there, you can always take out a common factor. Ne? But if you use a quadratic formula, you'll still get the same answers. If you use your quadratic, your a will be 3, your b will be -10, your c will be 0. Right? Perfect. But in this case, I'm going to take out a common factor of x. Here I'm left with 3x, so that when I multiply back, I'll still get that. Then the negative is there, then I'm left with 10 equals to 0, right? Perfect. Then this guy will be equals to 0, so x equals to 0, or this guy will be equals to 0. 3x minus 10 is equals to 0. And then we can see that 3x equals to 10, then x equals to 10 over 3 if you divide by 3 both sides. Ne? Ladies and gents, do not round off if you get fractions. You only round off when you want to approximate in sketching. The only time you round off in function is when you are doing sketching. Ne? But otherwise, do not round off. We need exact points. Okay, perfect. So now we are going to do this. We have the two x values, right, on the turning points. So I know that, okay, TP1, the x value is 0. I don't know the y value, right? And then I know that the other TP is 10 over 3, but I don't know the y value as well, right? But the good thing is I have the function. Remember, I have the function as f input x equals to 1x cubed minus 5x squared plus 1. If you have a function and you have an input, you can input it into the function to get the output. If I have the output, I can output it on the function to get the input. Ne? So what I mean is this is my x basically. I can replace all the x's with 0 to get what the y is. So I'm going to say f input 0 equals to 1 0 cubed minus 5 0 squared plus 1. If you press a calculator, your answer will be 1 there. So which means the input of 0 gives you the output of 1. That is your first turning point. Now let's check with 10 over 3. Ne? I'm just going to erase here, there, and there. So we're going to check with 10 over 3 now. What do we get? We replace this with 10 over 3. 10 over 3. Okay, let's quickly press our calculators and see what it gives us. 10 over 3 in bracket cubed. All my substitutions, I always use brackets, okay? Cubed, and then minus 5 in bracket, 10 over 3, close bracket, squared, plus 1. I get, in this case, I get negative 473 over 27. You write it down there, ne? It's negative 473 over 27. Do we see it? Perfect. And now we have both turning points of a cubic function. A cubic function has 2 turning points. Okay, sharp. Now let's do the point of inflection of this function. The point of inflection. So we have the first derivative. I'm doing the point of inflection. A point of inflection, ladies and gents, is basically where the concavity changes. Let me just show you here. Let's say I have a cubic function like this. I'm just going to use 2 different colors for explanation purpose. Ne? This is your first turning point. That is your second turning point, right? There's a point here in between, ne? Where concavity is going to change. So what happens here is, here you are concave down because the graph here is facing down. See? Then here you are concave up because the graph is facing up. Okay, so point of inflection is the point where concavity changes. Sharp. Now, I'll show you how to do the point of inflection. Let me just rewrite the first derivative here, which is 3x squared minus 10x. Ne? To do the point of inflection, we need to do the second derivative. Ne? If you haven't watched the video on second derivative, you can watch it. So, second derivative is basically the derivative of the first derivative. So 3 times 2, it's 6x, right? And then let's see here. Here we're going to have minus 10. Do you see it? Sharp. And then this must be equals to 0. And then you solve for x. So you're going to say 6x, you take 10 that side, so equals to 10. And then x equals to 10 over 6 because I'm dividing by 6 both sides. Then which gives me 5 over 3. Right. Now, this is my x value on the point of inflection. Right. That is the x value on the point of inflection. I can show you another way to find it. If you take this x value and this x value, remember I said it's in between the 2 turning points. Ne? So let's see. So you're going to say 0 plus 10 over 3, and then you divide the answer by 2 is the midpoint. You still get 5 over 3. That's how you get it when you press your calculator. Perfect. And then now we have the input. We can put it in the f of x here to get what our output is, right? So basically, we're looking at f input 5/3 is equals to 1 5/3 cubed minus 5/3 squared plus 1. Let's see what does that give us. So we have 1 and then we have 5/3. And then we have cubed. Then we have minus 5. We have 5/3 squared. We have plus 1, which gives us negative 223/27. Right. That is basically your thing, your point of inflection. Why? So this is your input, that is your output. So your point of inflection is 5/3 coordinate minus 223/27. Right, ladies and gentlemen. If this video makes sense so far, please hit the like button and share with family and friends. Right? Please, ladies and gents, please. Okay, I can show you another way we could have found this. Remember, we said the point of inflection is halfway, right? So if you basically take this y value and this one, you add them together and divide by 2, it should give you this answer. The same way we did with the x plus this x divided by 2, it gave us that answer. Okay. And then that is it with the first one. I'm going to just pick the second one. This one is easy because it's more or less the same as this. You'll just have to multiply out first. Ne? So I'm not going to do that one. Let's take that one there with fractions. Ne? Sharp. So this one, we have f of x equals to negative 1/3 x cubed minus 1/2 x squared plus 6x plus 5, right? And then we're looking for the turning point. Remember, I said for the turning point, we need to do the first derivative, right? So the first derivative, here we're getting negative x squared, because this multiplied by that gives you negative 1. So let me say negative 1x squared. Here we get negative 1x plus 6. The answer must be 0. Remember, we said the gradient on the turning point is 0. And the gradient is the derivative, which is this guy here. Then from there, let's see. I'm going to switch all the signs here. Ne? So it's going to be x squared plus x minus 6 equals to 0. And then you can use quadratic formula, or you can just factorize this to be plus 3 and minus 2. Ne? Then we know that this guy will be 0. So x plus 3 equals to 0, or the second bracket must be 0 as well. Then we know that x equals to negative 3 or x equals to 2, right? And then from there, we have our inputs. We can easily put them there to get our y values. I'm sure you can do that, ladies and gentlemen, right? And then that will give you your turning points. Yeah? But the most important part about the turning point, you need to know that the first derivative must be equals to 0. Right. So now let's proceed. So I'm going to do f input negative 3 is negative 1/3 negative 3 cubed minus 1/2 negative 3 squared plus 6 negative 3 plus 5. Then let's see what we get when you press a calculator. So I'm going to have negative 1/3 negative 3 cubed minus half -3 squared plus 6 -3 plus 5. That gives me -17/2, which means the first TP is going to be -3 coordinate -17/2. Right. Now I'm going to replace -3 with +2 now. Ne? I'll just do it on a calculator. So replace -3 with 2, I mean, with +2. +2 here. So +2. I'm getting 37/3, which means therefore the second turning point will be, if it's 2, the answer gives us 37/2. Those are your two turning points. And if you need point of inflection, you can do the second derivative, or you can use the short method I showed you. So I'm just going to do the short method in this case. Point of inflection is basically, I'm taking the first x value, which is -3, and then I add the second one, I get the answer, I divide by 2. So my x value on the point of inflection is half coordinate. I take the first y value, which is -17/2. Then I add it to the second one, which is 37/2. Then I get the answer. I divide the answer by 2. I get 5. So that is my point of inflection. Or if you want to, you can use this method. No? You can use this method. You do the second derivative, and then you get your answer. Then you substitute into your function, you get your solution. No? Should give you the same answer. You can test it and see if you're going to get this. No? But otherwise, this is the end of this video. I hope it was helpful. Keep looking for more fire content that is to be loaded. Thank you very much, ladies and gents. Aluta continua.